Thank you so much for coming. I'm going to speed run a lot of these slides. I'd rather get to questions and answer, specific things that people in the audience are wondering about. But generally, I break this talk into two pieces. How do you make RAG systems work? And then how do you make them scale after you make them work? Generally, what I'm going to be discussing today are really large-scale agentic RAG projects. I'm not talking about how to do RAG on your desktop, how to do it for teams. A lot of these things are probably too much if you're trying to do it small scale. This is really when you're in the trenches. You've got business critical things that you're building. What do you have to do to get to that next level? I wanted to give you just kind of a taste of what we do so you understand kind of our views on some of these infrastructure problems. It's useful there. We focus on integrating lots of different open source software and various SaaS vendors, various different players in the space. We're very broad, and we spend a lot of time doing security, doing integrations between things. So a lot of what we're doing doesn't have a view about one particular way to do things. In every area that we talk about, there are great tools and great vendors that can help you. What I want to talk about is really the generic side. If you're starting from open source and you're building it from scratch, that's a good way to think about how I'm talking about this. So the good news, most production generative and agentic projects fail, including RAG projects. Doesn't sound very good news yet. Last week, I just randomly, I was in a room with about 50 CTOs for not really people in the AI space, just people doing kind of real business stuff. And the general consensus were about 10% of the projects they were seeing were successful. That tracks with general industry consensus that we're having a very hard time moving things into production as an industry. One thing I did want to say, though, is if we think about this kind of in the context of history, we're only 2 years into a lot of this. And, something like e-commerce, went from, taking credit cards on a website to really doing shopping. It took about 7 years. So this is something that's going to be ongoing. So what is the actual good news? The actual good news is, unlike some projects which are significantly harder, RAG projects can be successful. Now, there are things that make a RAG project more likely to be successful or not, and it's really about making things easier for you as an engineer. This is not to say you can't get on the axis of hard in some cases, but if you can shape your project at all, you're much better off if it's internal, because then you don't have to worry as much about toxicity and reputational risk. You want to fail small first, get some confidence. Async, if you can stop worrying about the user experience, sitting there waiting for all of these models to respond, going through the various layers of infrastructure you need to go through, it's going to be easier. Decision support systems are easier to do because you have humans in the loop. Follow some best practices, we'll talk about those today, and find the right supporting tools for your task. The real good news is I'm beginning to see some of these projects successful a lot quicker in 2025. I actually saw one last week that went into production after 3 weeks. It was an application in financial services that was focused on understanding tariff use cases. So portfolio managers wanted to understand, how, is my portfolio going to respond to tariffs? Who's in trouble? Where are things good? But the caveat to that is I'm seeing this quick release of individual RAG apps after a lot of blood, sweat, and tears the previous year. So it's not that people are starting from scratch and they have something that's they're really confident in without a lot of previous work. They're just able to do new RAG apps much quicker than they were the year before. So I mentioned you really, before you can scale a RAG, you need to get the RAG system to work. For decades, we've been saying don't prematurely optimize your code. It's more of a horrible strategy in this case than it is at any other time, because there are so many moving parts and so many things you have to redo if you're doing your optimization early. So the first thing I wanted to talk about is to kind of dispel notions of naive RAG. The way we talk about RAG generally is we have a corpus of documents or a database, support tickets, whatever it is. We ingest them, we use some embeddings models, we throw them in a vector database, and then users are going to query the vector database. We'll get some similarity results. We'll use that for context and throw it in an LLM. That absolutely never works. I've never seen it work in one case in the real world. And generally, there is a lot of snake oil out there. I've begun to see a lot of consultants going out to people and saying, hey, you can do these few things and you'll have a RAG in 6 weeks. It doesn't work that way. It just does not. How I generally think about RAG, and some of this is because of what Cake does, but I generally think about a lot of different moving parts. The thing I want to emphasize here in this slide is that there are a lot of tools that you really need to think about, whether it's orchestration flows like a LangChain and a LangGraph, things like model servers. We see probably half and half of our customers using internal models. We have a lot of customers in regulated industries that can't egress data, so they'll run a VLLM and a Llama 4. We have other customers who are maybe in the healthcare space and they're okay with a Bedrock and being able to sign a BAA with them to get access to Anthropic's latest Claude model. It really is a lot of different tools, a lot of different things you need to think about. You're going to need to think about scaling. Are you running on Kubernetes? Can you auto scale up nodes if you need to do that? What kind of tools are you using to rebuild these flows? We'll talk all about those in this session. But if you forget everything else from this talk, there's one thing I really want to emphasize, and that is you need to produce evaluation sets. You need to understand what good is to get better. The thing that I think throws a lot of people off on these systems is, unlike most software systems, when you start out, it feels like you're 60% there. When you just run your first runs, oh my gosh, this is so much better than I thought it was. And they spend the next 9 months flailing. And the reason they spend the next 9 months failing is they do not know how to get from that 60% to 80% or 90% or 100, whatever kind of that success metric is. They're shooting in the dark, and sometimes things get better, sometimes they get worse, and they never can tell. I want to mention team just a little bit, because unlike in the predictive ML space, one of the cool things about ChatGPT and API models is, in the old days with predictive, we had to train our own models. We always had to host our own models. In this world, you can wrapper this black box. And what that's encouraged is teams that don't have some of that data science background and understanding why evaluation sets need to exist. Having some of that skill in your project is really important. It's also really important not to treat your RAG as a magic box. We've almost learned the bitter lesson too well when we're talking about RAG systems. We are not at a point where these models are magical. We absolutely have to build a lot of software infrastructure today. It's just impossible to release something really good in production with just an LLM and a little bit of stuff around it. And so it's a lesson to really to take to heart. So what should ground truth look like? You should have questions, answers, and citations, at least that, at a minimum. And how big that set should be, it's really going to depend on the area that you're working in. Sometimes it can be hard to get 50 examples, and even 50 will help you a lot. But the more, the better. You may want to do some synthetic data generation, but you need a few from subject matter experts for your customer or for your team. Tools to build the evaluation sets. From an open source standpoint, Label Studio is great. You want some sort of UI where annotators can paste and highlight things and make changes, evaluate thumbs up and thumbs down things. Having dashboards with things like Ragus, Deep Checks, Lane Fuse, Phoenix that ingest these triples and run automatic grounding checks and surface them to the team. Git-based versioning of those data sets. You're going to want to do lineage at some point. At some point, someone's going to tell you, hey, we really need to understand how we train the system. Inline feedback, you really need to be able to gather feedback from users of the system. Sometimes the best ground truth that you'll get over time is from people actually using the system. That's one of the better ways to gather ground truth, if you can start a beta or a pilot of stuff. Just kind of user interface of Label Studio. When you're talking to SMEs, you really need to brief them on how you want to get data. One of the first conversations as you're building the system should be with your subject matter experts. You need to teach them to write realistic questions, show them what a good minimal answer looks like. You may not have any idea when you start out, but work with them on what they're trying to get out of this and iterate with them on how to get to a good minimal answer. And then show them how to highlight an exact passage in a document so that you can teach these systems. Set acceptance rules, things like no ambiguous wording. Give tooling walkthroughs. Doing Loom videos to show people what you're doing so it doesn't seem super mysterious to the subject matter experts is important. Motivate them with their impact. Sometimes they'll think of it as drudgery. This is one of the absolute most important things. This is gold for the system, and make them feel special. Finally, this is dual use stuff. Part of what you should be doing when you're working with your subject matter experts is learning the domain. If you're not already part of that domain, you really need to understand how this stuff works, because you will be going back and you will be reading logs, traces, etc. You need to have some of the business in your head when you're doing that. Other things for evaluation help, automated judges. So LLMs, rubric prompts to do faithfulness and grounding. You can trade off experience for the user, cost and latency for accuracy a lot of the times. If you cannot afford the latency or the cost for doing additional judges on every prompt, make sure you're doing it out of band. Make sure you're gathering that data nightly to see how good your answers actually are. I'm going to move a little bit quicker here. What are some other reasons that naive RAG can fail? Magical belief in chatbots. Assuming raw text is enough. This is something that happens over and over again, especially like in financial services and healthcare customers. A lot of the time, if you just go through and take a PDF, turn it into text directly, you will lose a lot of table formatting. You'll lose information on but maybe you have a document that's composed of smaller documents that people pasted together. You might not know where one part of the document ends and one begins because you lose that font information. You really have to think about when you're doing the extract how you're going to pull that information out. Low precision in the prompting regime. If you're just doing very simple prompts, you're likely going to get high hallucinations. It's getting better with the models today, but we're still not out of the woods there. Let's see. Move forward. Another thing to talk about is how you work with teams that are building the system. You will almost always have to build a much more complicated system than you expect at first. You will throw away different ideas that you have, different flows. You can do that in a LangGraph or a LangChain, Llama Index, whatever the orchestration tool is. You can do that in code, but generally the teams that I see that are building this have problems if they can't see things visually. If they just can't see that visual flow, they can't try things on the fly, have playgrounds to check things. It becomes difficult. So I really recommend a tool like a LangFlow, a FlowWise, N8N, a LangSmith, something like that to go in and refactor the flow. Opinionated defaults and guardrails to prevent anti-patterns before things get into production. So this is, if you're using these low-code tools to expand the type of team that can build these flows, you do not want to give it to them de novo. You need to build some components for them that are well built to begin with the right way. So just an example. A lot of things you'll need to execute in parallel. If you have Ray in your organization and you're doing things through Ray, have your code snippets already calling out to Ray. You shouldn't have to have somebody learn Ray on the fly that is expected to build things with a low-code tool. These tools are useful for cross-functional collaboration, so domain SMEs can sketch out these flows with the developers. They're useful there. And they're learning by example. These tools tend to have templates that can kind of help you out there too. Just an example of this is LangFlow. Tracing tools. Advanced and agentic RAG systems can be hard to debug. Way too many distributed components to understand just on their own. So you want a tracing tool like a LangFuse, like an Arise Phoenix. Those aren't optional. You want to push the stuff out to OTel, the entire span of the flow. You want every component that you're calling in that flow to be writing out so that you can keep track of those traces. You should be pushing them into a store like a Datadog or a CloudWatch if you're in AWS. That way you can very easily get to them. They'll be with the rest of the logging information from other systems in the organization. But you can also pull those logs out and reuse them in data sets that you're using to fine-tune models later. Tracing tooling, this is just Arise. Don't hand in engineer prompts, automate them. This is something people can get stuck into that have been doing this for a while. If you haven't used like a DSPY, I really recommend getting experience with it. It can save you a lot of time. If you are going to automate prompts, you should be generating a lot of prompts. That means you need a prompt monitoring, model monitoring, comparison dashboard. The type of thing, PromptFoo is an example in the open source world of this, where you can create an evaluation set, You can evaluate on different axes, like whether users like it, what the latency is, what the token cost was, various metrics like Rouge scores, perplexity, etc. Lots of use for a tool like that, and lots of use for a tool like DSPY to generate prompts. Prompts are kind of the bread and butter at the lowest level on how we make the system better. Being able to generate a lot of them and being able to evaluate them is critical. Okay, so we have a vector store of some sort. Is vector search enough? Almost never these days. If you're not, you should just start out with hybrid search. I'm not aware of any case where it makes sense to start out with just a vector search. It can be cheaper, but if you're doing a complex system, generally you want similarity, whether you're using sparse vectors or dense. Similarity is cheap, it's quick, as long as you're re-ranking things, you want more of that, less calling out to LLMs. So generally, you want to do some sort of hybrid search. Graph expansion, so GraphRAG. By the way, I tend to caution against using GraphRAG, the framework itself. It's slow. There are better solutions these days. Things like LightRAG. There are a bunch of things out there now. You may want to do entity extraction. Where entity extraction and GraphRAG systems help you is in two places. One, it is very hard to do breadth-based search in these systems unless you have some way of linking different nodes better than just similarity. I won't go into too much detail there, but the other place that helps you is hallucination. But if you are going to have to do some breadth-based search where you need to understand across your entire corpus something, like if you, instead of trying to understand a particular company in a set of financial documents, you need to understand an industry, you need something like a graph to bring things together. Other retrieval suggestions, things like use metadata to filter your search. Two-stage course-to-find searches, so have different indexes. Reciprocal rank fusion is always a great idea. Refining your HNSW configuration in your vector store. Re-ranking. This is probably the first thing that people do when they graduate from naive RAG to something else, and I don't want to leave it out. Re-ranking your results is incredibly important. Hybrid search makes the search results a little bit better, but you will also always have failures of similarity search. That means you need a re-ranker to do things. You may want cascaded rankers, some of the more expensive ones for just a few of the items, and some of the less expensive ones to do gross sorting. Let's see. Okay, agent actions. So we're in an agentic world now. MCP is making everybody crazy these days. Everybody's adding MCP support. I think most people know this here at Data Council. MCP is not a silver bullet. It's cool. There are things that MCP is really going to help with tool use, but it's not a silver bullet. Neither is any other specific agentic framework. They are tools, just like all of the other tools in this toolbox. MCP, if MCP is going to be everywhere and you're going to be doing a lot of tool use, just understand there are a lot of security implications to using MCP on tools. If you're going to let them, use, your Salesforce, that might be a problem for the organization. So you need to think about sandboxing these tools. Guardrails. So as your agents are gathering data, putting things together for responses, JSON schemas, pedantic, are your best friend. A lot of the time, Much of the hard work is just getting the output munged into a format that you need to use downstream in your RAG workflow. Human in the loop is critical. So think about the human in the loop capabilities of any particular framework. Most of them have some human in the loop, but some do more than others. Real-time agents and streaming. So you may want to use RAG in the case of a real-time agent. So you got a video sales call and you want it to talk through your set of documents. That is much harder than everything else that we're talking about, and it requires a completely different presentation to talk about. So if you're doing real time, understand that's a big deal. Too many steps is deadly. There was a Honey Hive presentation earlier in the session, and kind of they drove down the point on that if you have 5 steps or more, you're going to start accumulating failures really quickly with your agents. And those errors cascade and accumulate. A tiny number of errors in each step in the process means that almost no process is ever successful. It's kind of like 5 nines. You're like, oh, I just had a little downtime in this system, a little downtime in this system, and pretty soon you have a system that almost never functions. Let's see, more things. Real-world documents have structures that should be engineered around. Financial data. Table extraction is a hard problem. If you have to do that, it is very, very hard on its own. There are frameworks like IBM's Dockling that are really cool. It's gotten much better in the last 3 months, but it's one of those areas you really need to think about. You're going to want to modify the user's query. You don't just take the query as is, send it to the vector store. You will want to rewrite it. You might expand acronyms. I call, there are other terms for it, but I like to call one thing anti-jeopardy mode. So instead of asking the question the user asks, just send it to a simple LLM, get its random answer, use that to query your vector store. You're going to get better similarity. There are a lot of interesting ways to do this. Context boosting, add session keywords, etc. Lots of other tricks. You should almost never emit an LLM response directly. You should change format, add legal boilerplate at the end of the responses, etc. Lots of different scaling dimensions to think about. Generally, users and requests are one scaling dimension. Large sets of documents are the other. I recommend tackling large sets of documents first. And note, massive context windows will not save you. They are going to make some things harder. The LLM now has more that it's got to pick through. So here is a list of RAG scaling dimensions. You can watch the video and go through some of these. But there are a lot of different dimensions. Splitting and chunking, you really need to think about your chunking strategy. If in your vector store you really have disconnected chunks, you don't understand the context of a company because you split at the paragraph level, it can cause problems. You should dedupe before you chunk things up. It makes it more simple to find the right stuff. Consider a parallel compute engine during ingestion. You should never do ingestion without parallel compute. Entity extraction, you need to do it with a fast framework. Speed it up yourself if you can. You want to have the link source when you're capturing things so that you can. Almost all systems using RAG will want to show context to a user. You need to capture that context when you're chunking things. Semantic tiering of vectors. Vector databases tend to store a lot of their retrieval results in memory. If you have a lot of documents, this can make things very expensive if you're not able to tier things. Let's see. Yeah. Re-rank everything for a schema tweak could result in multi-day outages if you don't plan very carefully. You don't want to be doing re-indexing of everything. You need to split things into collections. There are a lot of things you can do to make this stuff scale up. Serving models. Consider performance-focused inference engines like VLLM if you're self-hosting. On the opposite side, as you're developing, use experimentation-focused engines like Ollama when you're trying out new things. It's very hard to get things right with VLLM. It's very hard to make things fast with Ollama. I love using a proxy like Light LLM if you're self-hosting, Open Router if you're in if you're external. You can call things like Bedrock or OpenAI with Light LLM too. If you are going to, if you have kind of choppy inference, consider adding something like a RAY-serve in front of VLLM or Ollama. RAY-serve can, along with the Kubernetes, can help you auto-scale up your models. Model metrics that you should really be paying attention to if you're self-hosting: latency, request rate, error rate, CPU usage, memory usage, GPU usage, and the most important, GPU memory usage. That's the one that's going to bite you most of the time in these. API models, token throughput, quota remaining, cost, user metrics. By the way, just a weird thing to think about. AWS has Bedrock and can call out to Anthropic. We have a lot of customers that need to go through Bedrock because they have HIPAA requirements that they need a BAA. AWS will sign that. The problem is you won't get as much data on failures and quota approaching, things like that from Bedrock that you do if you're calling Anthropic directly. So don't trust API models. So this is not pointing a finger at any vendor. Everybody is bad in this space. But number one, the way our models work do not conform to the way enterprise software companies think about things. The models suddenly stop working immediately because of a rate limit. They change something behind the scenes, and so accuracy plummets. So you need to have some strategy to deal with it. It doesn't mean you can't use those models, but you need to understand when things are getting weird. You need to have dashboards to. It's kind of the way we dealt with drift in traditional ML. You need to understand when the world has changed out from under you, or you need some way to pin a model. Let's see. Always capture live user feedback. You will not be able to progress after you've deployed if you're not capturing that feedback. It is a gold mine. Let's see, canary gating of features. As you add new features to your RAG, you need to capture it behind canary tests. More observability, regression detection workflows do a similar job to drift detection. Let's see, and triggers that balloon costs. If you're embedding everything and ingesting it, even logs and CSS, your storage costs are going to balloon up. You have lots more vectors. It makes it harder to find the similar things. Re-rank cross-encoder on every query, regardless of queries per second. That can slow things down. Anyway, I think that is a whirlwind tour of some of these things. Any questions anyone has?